a simple exponent property like this. Let's just say it's x squared y cubed to the power of 4. Something like this. The rule here is that you take the exponent, which in this case is 4, and you distribute it. In the case of here, you're multiplying. So it literally becomes x to the 2 times 4, which is really x to the 8th, y to the 3 times 4, which is 12. You just multiply the exponents. Is that clear? Is that something you saw in class?
Yeah.
Okay. Where it gets a little bit more difficult is when you have a number inside. So let's say it's like 3x squared y cubed to the power of 2. There's really an exponent of 1 above the 3. So you're taking this 2 and distributing it to each of those. So you're multiplying the exponent by 2. 3 to the 1 times 2, which is 3 squared. X to the 2 times 2, which is x to the 4th. And then y to the 3 times 2, which is y to the 6th. So that's 9x to the 4th, y to the 6th. Is that okay?
Yeah.
All right. What if x and y are written like this? What is the exponent that's unwritten here in each of these?
5x y5.
Right. There's really a 1 there. And so it's x to the 5, y to the 5. Okay. So let me have you try one on your own here. Make it too difficult. Let's go 4x to the 8th, y squared to the power of 2. Could you give this a try, please?
y2, 2, 2. Okay. So y to the 4, x 4 to the 2, x to the 16. 4 times 4 is 16, x to the power of 16, and then y to the 4th power.
Very good. Really good. Okay. Let's move on to standard form.
Okay.
Unless you want more of those.
Standard form is fun.
Okay. I'm going to write something that is in standard form. 7x squared minus 13x plus 5. The reason this is in standard form is because it's in descending order. Descending order refers to the exponents. So your focus, if I have all the exponents written, it's a 2, it's a 1. But you might ask about the 5. You're like, where's the exponent for 5? Well, unwritten is an x to the 0 power, which you don't need to know about, but that's why it's called descending order with the exponents, because there really is a 0 there. It's just not written. Okay. And the idea here is that the operator goes with it. So this is really minus 13x. Okay. And it's not written, but there's really a plus in front of the 7. So it's really positive 7x squared. And so on. So what they do is they will be disruptive, and they'll disorganize this. They'll write -3 minus 4x minus 5x squared. But here's what you have to do. You have to say, okay, it's really -3 minus 4x minus 5x squared. Okay, and you just grab them and basically regroup them. You're like, okay, well, that minus 5x squared goes first. Then you grab the minus 4x, it goes next. Then you grab the -3. And you're like, well, it goes last. Has to be in descending order. The operators go with the terms. So let's look at another example here. Let's say it's -3x squared plus 2 minus 8x. what should come first out of these three terms? And I'll circle them again.
Negative
Oh,
3x squared,
okay. So
and
you'd write
then
minus 3x squared. Good. Keep going.
negative 8x, and then plus 2.
Plus 2. So you got it. No big deal there. Okay. So this moves into what's called combining like terms. Okay. Hopefully you heard something about that in class, or that doesn't sound totally unfamiliar to you.
Yeah.
So as a basic example, sorry, that was really bad. As a basic example, the reason we can add 7 and 3 is they are like terms. 7x plus 3x is 10x. Again, those are like terms. You're like, I got it. Well, what is 7 plus 3x? Are these like terms? And the answer is no, they are
No.
not like terms. It's just 7 plus 3x. So let me give you a few examples here. Let's say you have 5x plus 6x squared. These are also not like terms. And you might be saying, well, wait, they both have an x in it, right? Well, what's the power of x here, though? 2. And here it's a 1. So this is just 5x plus 6x squared. Is that okay?
Yeah.
So you can only combine stuff if it's like terms. So here's a problem. Let's say it's 7 plus 5x minus 3 minus 2x. What can you combine here? What are the like terms?
5x and negative 2x, and 7 and negative 3.
Okay. Can you give me the result after doing that?
3x minus, 3x plus 4.
Good. This is in standard form because it's in descending order. That's great. Let's make one a little bit more difficult for you. Let's go minus 2x squared minus 3x plus 5 plus 4x squared minus 3x minus 7. So I'm just trying to really up the difficulty here. You're doing a great job. Give that a try, please.
So 2. Minus 6x. Is it 2x to the power of 2
Good.
minus 6x,
Good.
and then minus 2?
Yes. Very good. Okay, doing great. So occasionally you get some problems like this. You get something like 4x plus 7 plus 2x plus 8 plus 4x squared. Just keep the numbers nice here. And you have these parentheses and you're like wondering, well, why do you have parentheses? The parentheses are only needed in two situations. The first is when you have a subtraction sign in front, which you don't have. There's nothing written over here, but you can assume it's a plus if nothing's written. Plus is here. The other thing that could be an issue is if there's a number in front, which you also don't have. So in other words, these parentheses are unnecessary. Basically, you can drop the parentheses. So it becomes 4x plus 7 plus 2x plus 8 plus 4x squared. Okay, so could you combine like terms here for me, please?
4x squared plus 6x plus 15. 4x squared plus 6x plus 15.
Really good. And what I like most is you automatically put it in standard form because that's what they want. Even though they don't say it, it's implied. All right, so here's another problem for you to try. Let's go 2x squared minus 8x plus 3 plus 5 minus 4x minus 6x squared. Go ahead and try that one, please.
4x squared minus 12 plus negative 4x squared minus 12x plus 8.
Very good. Really good. Okay. All right. So the next type of problem you'll see is where they just put a negative out in front. It'll be like negative, say 8x squared minus 3x minus 4. And when you see this negative out in front, it means to distribute that negative to everything. And in other words, you're going to change the signs. Change the signs. So whatever it is inside here, like notice that 8 is positive, it becomes negative 8x squared. Positive 3x, positive 4. Okay, and then typically a problem like this is paired with something else, which will be like 7x squared minus 5. But the negative only affects the stuff on the right. So you bring the stuff on the left down, and then you combine like terms. So it becomes minus x squared plus 3x minus 1. Is that okay? Clear?
Yeah, but couldn't
So
you
I'm
just, like not distribute it, and can't you just do like 7x to the power of 2, just since there's a minus sign, minus 8x to the power of 2?
You have to give it to everything. It's a placeholder. It's like everyone's going to get this.
But can't you just like take the both numbers and just subtract them? Because wouldn't that equal the same answer?
I guess I'm not following. Like what I heard is that you're only going to give it the first one.
No, I'm saying like, okay, so if you take like -5, right? And there's
Yes.
-4, can't you just subtract -5 and -4?
It only goes to the one on the right. It only applies to that, to
Well,
the
no,
right, not to the
okay.
left.
No.
Sorry, I'm just
Okay,
not
what
understanding.
I'm saying
I'm
is,
not
okay, so
understanding.
you know how there's a -5 on the left,
Yes.
and then there's a minus symbol.
Yes.
So think about it like you take away every number, and then it just becomes -5 minus, because there's a minus symbol, -4.
Yes. That also works.
Okay, okay. See,
Yes. All right. So let me give you another problem here. 3x squared plus 4 minus 7x minus 6 minus 2x plus x squared.
oh, um, so 4. Oh wait. 2, 7, 5. So minus 5x plus, wait, minus 6. Is it 2x to the power of 2 minus 5x minus 2?
Minus 5x, and then yes, minus 2. You got it. Really good. Really good. Okay. Yeah, I mean, that actually covers everything. You did really well. Do you want me to give you more examples, or do you want us to?
Hold on. I can send you more.
Yeah, we got a couple minutes left here before switch over to Brooke. So
I'll do the front side. Wait, no.
all right, yes. See one more thing here. All right. Let's talk about this first function here. I'm sorry, equation. Y equals 3 times 2 to the x, and it says to graph. What I'm not seeing is a table. Maybe you just did it by hand without the table, but I'd really like to see some values in here, x and y, and we can start with nice values. We can start with like 0, maybe 1 and 2. So what this means is you're putting 0 in for x, 3 times 2 to the power of 0 on your graph. So I got there's the table. I just saw it, just didn't catch it. This ends up being 3, which you have. 1 ends up being 6, and then 12 for them. Very good, very good. Okay. Now the problem is going the other direction. The other direction, because these exponential graphs, they always flatten out. And I'm not seeing that on your graph. So unfortunately, we have to deal with negative exponents. Do you remember anything about negative exponents? I was trying to avoid talking about that, but we can't.
Wait, what?
You remember anything about negative exponents, what they do to this 2?
Mm, no.
So it ends up flipping it. Like it's really 2 over 1, and you flip it to become 1/2. And so 3 times 1/2 is 3/2. -2 is, and I'll need just a little more room here to write this. It's y equals 3, 2 to the minus 2 power. But 2 is really 2 over 1. So you end up flipping it. It becomes 1 over 2 to the power of 2. You're flipping what's inside there. And then you change the negative to a positive. Then you have to square both the top and the bottom. Am I speaking a foreign language right now, or is it just
Hold on. 2 over 1. Wait, so if it's a negative, do you put it over the negative? Like you put the number on the bottom or the
you
top?
flip the number? So 2 is really 2 over 1. So when you flip it, it becomes
So
1/2.
So do you put them all over 1?
Just if they're whole numbers.
Oh, okay.
Like if it was 3/4 to the -1 power, it would become 4 over 3.
So you just flip it. So just okay.
Yes,
That makes sense.
yes. All right. Okay, we're kind of at our stopping point here. I know that was maybe unclear. What I was trying to get you to see is that the graph that you have, you've kind of got this part of it. You got to show it going down
Oh,
to,
did I not finish it?
it looks like, yeah, you need a few more points here. And that's what we were going to see, is that basically they get closer and closer to 0. So kind of like you can envision like something landing softly or a smooth thing there. All right, we do have to stop here though, unless your brother doesn't want any time today, but I think he does. You know, he's a little bit struggling.
I'll go get them.
Yep.